In this video, I'll show you how to express a rational function as a sum of partial fractions to integrate. This is question 1. The goal is to convert this function into this function, because equation 2, this one, is a lot easier to integrate than equation 1. Yet, they are the exact same. If you find a common denominator here, you'll end up with this function. And the reason why this one is easier to integrate is because the integral of 1 over x is simply ln x plus whatever is being added to that variable. So if we can somehow convert this into this, then we should be able to integrate really quickly. The technique used to integrate a rational function as a sum of partial fractions is summarized below. And we will use this technique for the question that we are integrating. This method only applies if the highest power in the numerator is less than the highest power in the denominator. So take a look at your function. Notice that the highest power in the numerator is 1 and the highest power here is 2, so this technique will work. And here's what you do. You will first factor the denominator. And this trinomial quadratic is totally factorable. What two numbers multiply to negative 2 and add to 1? Those numbers are 2 and negative 1. 2 times negative 1 is negative 2, and 2 plus negative 1 is positive 1. So let's rewrite this function in factored form. The integral of 4x plus 5 over x plus 2 and x minus 1 dx. The next step is to count how many factors there are in the denominator. There are two. There are two numbers being multiplied to each other, and as a result of that, we will rewrite this in the following way. 4x plus 5 over x plus 2 x minus 1 is equal to a over x plus 2 plus b over x minus 1, where a and b are constants, they're numbers. Next, I will find a common denominator on the right side here, and I can do that by multiplying the two denominators together and then cross-multiplying the two denominators with the opposite numerator. And this gives me, so what I did is I multiplied the two denominators together and then I cross-multiplied. Notice that the denominator on the left side and the denominator on the right side are the exact same. So we don't have to keep those in mind when we try to solve for a and b. We can simply write the numerators like this. And our goal is to find out what a and b are. The first method is similar to solving a system of linear equations where you have to match the coefficients. Let me show you what I mean. You have to expand the right side where you end up with 4x plus 5 is equal to ax minus a plus bx plus 2b. Once you've expanded the right side, you will now match the coefficients. So we have 4x, ax, and bx, and we have 5, negative a, and positive 2b. What I mean by matching the coefficients is now you write down 4x is equal to ax plus bx, and for the other equation we have 5 is equal to negative a plus 2b. Now since we're only focusing on the coefficients, we won't write down the x's. And now we have a system of linear equations. Pretend that this is x and y as we normally have when you use elimination or substitution, whatever the case may be. So to solve for our a or b, you can simply add the two equations up. If you add these two equations up, you end up with 9 is equal to a plus negative a, which is equal to nothing, that goes to 0, and b plus 2b is equal to 3b. Therefore, 9 over 3 is equal to b, and that is equal to simply 3. So we just found our b. We can find our a by substituting this number back into any of these equations. For example, if I substitute this back into there, I end up with 4 is equal to a plus 3, and a is equal to 1. So I just found my a and my b value. That's the first method. Another method is to use guess and check. what will make this variable go to 0? If you say x is equal to 1, and you apply x here, this goes to 0, and you're left with 4 times 1 plus 5 is equal to b. 1 plus 2 is 3. And if you solve for b, b is equal to 3. Don't believe me? Try it yourself. 4 times 1 is 4, plus 5 is 9. Divide both sides by 3, and there you have it. So if you do the same thing, if you set x is equal to -2, that will make this one go to 0, and then you can solve for a the same way I just did for b. A is equal to 1. Now that we found our a and our b, we can go back to this part and apply 1 into here and 3 into there. So let's do that over here, where we have the integral of 1 over x plus 2 plus 3 over x minus 1 dx. I'll use this fact that the integral of 1 over x is the ln of x plus n, where n is a constant, and that's an absolute. So we have the integral of this is ln x plus 2 plus 3 ln x minus 1 plus c. I apologize if this is all crammed up on this side, but that right there represents the integral of the following function. And there you have it. That is how to express a rational function as a sum of partial fractions. Make sure to watch question 2 for another example.